Right, yesterday you guys started with graphing two lines on one coordinate graph. We're going to do that again today, but today we are looking for their point of intersection. Yesterday we were looking at if they were parallel or perpendicular, and we noticed that the perpendicular lines did intersect. These lines today are not necessarily going to be parallel or perpendicular. We are looking for an exact point that they run into each other. So what we are working on doing is solving each system of equations by finding the point of intersection. So because we have two equations, it's called a system, and we solve it by finding the point of intersection. So remember, in order to graph these equations, we need to have them in slope-intercept form. So we have y equals negative x plus 4 and y equals 1/2 x plus 1. Both are in slope-intercept form, so we'll go ahead and just graph them. Our slope here, remember that's negative 1, so we have negative 1 over 1, and our y-intercept is 4. So we're going to go up 1, 2, 3, 4, and then down 1, over 1, down 1, over 1. You need to be careful and make sure that you extend your line long enough so that when we put the other line on top of it, they run into each other. And you need to be careful that you're very accurate in graphing the lines so you can see the exact point of intersection. Y equals 1/2 x plus 1. Your slope is 1/2. Your y-intercept is 1. So we're starting at 1, and we're going up 1 and over 2. Up 1, over 2. So this one's pretty easy to determine where they are running into each other. And so our solution is the ordered pair where the two lines intersect. So this is over 2, up 2. So our solution is 2, 2. Next one we have 3y minus 6 minus x equals 0. And we have y equals negative x minus 2. This equation's all set. This one we need to get y by itself. So we have 3y minus 6 minus x equals 0. We could add 6 to both sides. And then we have 3y minus x equals 6. We have to add x to both sides. So that gives us 3y equals x plus 6. Last step, we need to get y by itself, so divide everything by 3. Y equals 1/3 x plus 2. Remember, there's an imaginary 1 there in front of the x, so that gives us 1/3. 6 divided by 3 gives us 2. Our slope is 1/3. Y-intercept is 2. So we start at 2, 1, 2, up 1, over 3, up 1, over 3. All right, next equation, y equals negative x minus 2, so our slope is, remember there's imaginary 1 there, so it's negative 1 over 1. Y-intercept is negative 2. So we start at negative 2, down 1 over 1, down 1 over 1. So we can probably pretty easily see where they're going to intersect. Draw the line. And our solution is over 1, 2, 3, so we have negative 3, and up 1. Next equation, negative 3y minus 9 equals x. We need to get y by itself. On the other side, we have y divided by 2 equals x plus 2. So we need to work on both of these. Add 9 to both sides. We have negative 3y equals x plus 9. Next, we need to divide everything by negative 3. So we have y equals, remember there's an imaginary 1 in front of this x. We have a positive divided by a negative, so that gives us negative 1/3 x. Positive divided by negative again, so that's negative 9 divided by 3 is 3. Our slope is negative 1/3. Our y-intercept is negative 3. So we start at negative 3, 1, 2, 3, down 1, over 1, 2, 3. And we go up 1 and over 1, 2, 3. To extend the line a little bit. And that line's all set. Now we have y divided by 2 equals x plus 2. We need to get rid of the 2 that is dividing y. So we multiply both sides by 2, cancels on the left, and then we have to distribute it on the right. So we have y equals 2 times x is 2x, plus 2 times 2 is 4. So we have a slope of 2 over 1 and a y-intercept of 4. So we start at 1, 2, 3, 4, up 2, over 1, down 2, over 1, and our point of intersection looks like it's right here, so it's over 1, 2, 3. It's negative 3 and down 2, so it's negative 2. We have, for example, 4, y equals 5, and y equals negative 3 halves x plus 2. Both of them in slope-intercept form. Example, for the first one, our slope is 0, and our y-intercept is 5. So we go up 1, 2, 3, 4, 5, make a dot. Our slope is 0. So it gives us a horizontal line. Y equals negative 3 halves x plus 2 gives us a slope of negative 3 halves and a y-intercept of 2. So we're going to go up 2 and then down 1, 2, 3 over 2. So we go up 1, 2, 3 over 2. And we can see where it hits the line. So our point of intersection is over 1, 2, that's negative 2, and it hits the y equals 5 line, so that's negative 2 and 5. Last one, y minus 2x minus 3 equals 0, and y minus 6 equals 2x. We need to get y by itself on both of these examples. So add 2x, add 2x. That gives us y minus 3 equals 2x. Now we need to add 3. So y equals 2x plus 3. Gives us a slope of 2 over 1 and a y-intercept of 3. So we go up 1, 2, 3, and then up 1, 2, and over 1. Down 1, 2, over 1. So everything looks like that. And y minus 6 equals 2x. We need to move the 6. So we'll add 6 to both sides. That gives us y equals 2x plus 6. We have a slope of 2 over 1 and a y-intercept of 6. So we go up 4, 5, 6, and then up 2, over 1, down 2, over 1. Looks like our lines are not going to intersect. And does it make sense? Well, if we look at the equations, Both of them have a slope of 2/1. So yesterday we looked at lines that had the same slope, and that meant that they were parallel lines. So they don't intersect ever. So what that means is for our answer, we have no solution, since they will not ever run into each other. Those are your notes. Please make sure that when you're working on your assignment, that you make sure you show your work, getting y by itself, showing your slope and your y-intercept, making sure that you're graphing all the equations and that they're pretty accurate. Have a good day.